this is the same as the natural log of A times B. Number 2, natural log of A minus natural log of B is the same as the natural log of A divided by B. Number 3, the natural log of A to the power B is the same as B multiplied the natural log of A. So we can see these rules are the same as the rules of logarithms. If you do not know the rules of logarithms, please check my videos on equations of logarithms. So the last one we'll take a look at is that if natural log of A equals B, then we can have e to the power B equals A. E to the power B equals A. Actually, E is the base of the natural log, which is approximately 2.718 and so on. You can find it on the calculator by shift natural log. You find E. All right, so let's have a look at it. If you have an equation, for example, number 1, solve this equation for x. If natural log of 3 minus x squared equals 2 natural log of x. In this case, we can apply law 3. Rule 3 says that natural log of A to the power B is the same as B natural log of A. Therefore, B natural log of A, the B becomes a power as line AB. So this becomes natural log of 3 minus x squared being equal to the natural log of x squared. This 2 becomes a power, just like here. Okay, we can go by this in 2 ways. One is we can take antilog of both sides. So if we take antilog of both sides, the logarithms will go. So let's consider both formulas, both method and see. Method 1 is we can take antilog of both sides. So the logarithm on both sides will go. And we have 3 minus x squared being equal to x squared. So we can have 2x squared being 3, or x being plus or minus the square root of 3 over 2. Alternatively, we can decide to bring ln of x squared to the other side, to the left-hand side. And we have the natural log of 3 minus x squared minus natural log of x squared equals 0. We take natural log of x squared to the left-hand side. Then we can apply rule 2. Rule 2 says if you have a natural log of A minus the natural log of B is the natural log of A divided by B. So in this case, is the natural log of 3 minus s squared over s squared equals 0, A over B. Then we can apply the last rule, rule 4. It says natural log of A equals B, then e to the power A, e to the power B equals A. So in this case, e to the power 0 equals 3 minus s squared over s squared. Of course, e to the power 0 is 1. So we can simply see that this is 1 equals 3 minus s squared over s squared. And we can group the like terms to have 2x squared equals 3, and therefore x is the square root of 3 over 2, just like we got. So each of them will give you the same answer. All right, let's look at another example. If you have 2 natural log of x plus 1 minus natural log of x equals natural log of 2x minus 1. We want to solve for x. We can apply rule 3 that if b natural log of a is the same as natural log of a to the power b, the coefficient becomes a power. So in this case, the coefficient 2 can become a power. So this will become natural log of x plus 1 all squared minus natural log of x minus equals the natural log of 2x minus 1. This is in the form of natural log of a minus b on the left-hand side, natural log of a minus b on the left-hand side. So we can say natural log of x plus 1 all squared over x equals natural log of 2x minus 1. Just like before, just like the previous example, we can take natural log of both sides. So let's consider method 1. If we decide to take the antilog of both sides, we have x plus 1 all squared over x being equals to 2x minus 1. And x plus 1 all squared becomes x multiplied by 2x minus 1. Of course, we can expand and simplify to get x squared minus 3x minus 1 equals 0 when we expand and group the like terms. We have this. And of course, we can solve this quadratic equation to get 3 plus or minus the square root of 13 over 2. If you do not know how to expand or solve a quadratic equation, please check my other videos on expansion of quadratic equations. All right, let's look at another method from here. Instead of taking the antilog of both sides, we could have taken the left-hand side we can take the right-hand side to the left-hand side to get the natural log of x plus 1 all squared over x minus the natural log of 2x minus 1 equals 0. This is the same as root 2, ln of a minus ln of b. So we can say the a part divided by the b part, which will be x plus 1 all squared over x, 2x minus 1 equals 0. Then we apply law 4. Ln of a equals b means e to the power b equals 4. So in this case, e to the power 0 equals x plus 1 all squared over x, 2x minus 1. And this is the same as e to the power 0 is 1. So it's the same as x, 2x minus 1 equals x plus 1 all squared. Remember, this equation here is the same as this equation here. It's the same thing. So when we continue, of course, we are going to get this expression and the same answer. All right, let's look at another example. If we have e to the power 2x plus 2ex minus 15 equal to 0, this can be written as ex all squared plus 2ex minus 15 equals 0, because e to the power 2x is the same as e to the power x all 2, and the same as e to the power 2 or x is the same, because a to the power m times n is the same as a to the power m or n. Okay. Now we can let any variable, let's say y, being equal to e to the power x. In this case, e to the power x to the power 2, so that becomes y squared plus 2y minus 15 being equal to 0. This is a quadratic equation which we can easily solve. If you do not know how to solve quadratic equation, please check my videos on quadratic equations. So in this case, we have y equals 3 or y equals negative 5. But we know that y is actually e to the power x. So we can say e to the power x equals 3 or e to the power x equals negative 5. But as we know that e is the base of the natural log, which is about 2.718 and so on. So e to the power x can never be negative. E to the power no number will be a negative number. So e to the power x cannot be negative 5. So the only solution that we have here will be when e to the power x equals 3. We can apply natural log to both sides. So we have natural log of e to the power x equals the natural log of 3. In this case, this comes to root 3. If natural log of a to the power b, b becomes a coefficient. So x ln e equals ln 3. Of course, we can divide both sides by ln e to become ln 3 over ln e. Actually, ln e is 1 because e is the base of the log. The logarithm of any number to the same base is 1. Logarithm of 2 is 1. So since e is a base of log, ln of e is 1 because the base is e. So ln e is 1. So of course, the exact value is ln of 3. This is the exact value. Of course, you can decide to write x is the same as 1.099 to 3 decimal places. Let's look at the last example. So if you have 6e2x minus 13ex minus 5 equals 0. The same approach, this can be written as 6ex all squared minus 13ex minus 5 equals 0. We can let any variable, let's say w, be equal to e to the power x. So this becomes 6w squared because this is e to the power x, which is w, minus 13w minus 5 equals 0. We can solve this quadratic equation. If you do not know how to solve quadratic equation, please check my video on solving quadratic equations. So w becomes 5 over 2, or it is negative 1 over 3. But we know that w is actually e to the power x. So e to the power x is either 5 over 2 or e to the power x is negative 1 over 3. As I explained before, e is the base of the natural log, which is about 2.71 and so on. It can never be negative. No value of x can put e to the power x to be negative. So e to the power x cannot be negative 1 over 3. Therefore, we need to solve for e to the power x is 5 over 2. We can apply log to both sides. So we have natural log of e to the power x being equal to natural log of 5 over 2. By this law, ln of a to the power b becomes a coefficient, b ln a. So ln of e to the power x becomes a coefficient, natural log of 5 over 2. So we can divide both sides by natural log of e. So 5 over 2. So remember, natural log of e is actually 1, as I explained before. So it's simply divided by 1. And this is the exact value. X equals natural log of 5 over 2 is the exact value. Or you can round off your answer to 2 decimal places by using a calculator. Anyway, if you like this video, please subscribe to my channel.